soil failure or differential settlement. So one by one we will discuss all those type of failures, and we will see how we can ensure the safety against those failure modes. So settlement becomes excessive if the applied loads is larger than the capacity of soil. So if the applied load is more than the capacity of soil, or the contact pressure under the foundation is more than the capacity of soil, so in that case settlement becomes excessive, or the soil can fail. The size of footing should be such that the gross contact pressure under the footing due to service loads, including backfill, surcharge, weight of footing, should be less than the soil allowable bearing capacity. So the gross pressure under the footing should be less than the allowable bearing capacity. So if we satisfy this condition, in that case our structure will be safe against the soil failure. To avoid the differential settlement, we can play with the shape as well as the type of footing. As we have seen in case of types of footing in the previous video, so we have seen if there is a possibility of differential settlement, we can use combined footing, strip footing or raft footing. So here in this figure we can see if the whole structure settles, so in that case our structure will not have any crack. But if it settles linearly from one side to the other, the settlement is linear, here the settlement is more and here the settlement is less, in that case there is a possibility of overturning, and this building will overturn when the centroid of the mass of this building crosses or lie away from this bearing area. Otherwise this will remain stable. But the most critical is if the settlement occur in some part of the building. So in that case the structure can collapse, or there may occur large cracks in the walls. So if there is a crack, inclined crack or vertical crack in the wall, so that may be because of differential settlement or settlement of the some part of building.